Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be covering 7.2, which is looking at graphing logarithmic functions. Because we're doing this online, we're going to be using Desmos primarily. We're going to talk about a couple techniques that we can use to sketch a function if we were doing this in person or doing it by hand. But the idea is to be able to understand what the general graph of a logarithmic function looks like, and then also be able to sketch it and be able to talk about domain, range, end behavior, all that good stuff. So let's go ahead and get started. As I've mentioned in 7.1, your logarithmic functions are inverses of exponential functions. So if I take an exponential function like 2 to the x, and I graph that next to a logarithmic function, we can see that these are inverse functions. The input and output are being switched, and so we can see that those asymptotes are also changing here. Whereas in an exponential function going to the left, I have an asymptote on the x-axis. For a logarithmic function going down, I have an asymptote on the y-axis. A couple things real quick. If you are typing this into Desmos, anytime you're typing below your normal line, that's referred to as a subscript. So most of you know by now that if you want to do a superscript, like an exponent, you'd be typing in the caret key, and that'll tell Desmos to type up. So if you want to do an exponent, okay, that's how you do your superscript. If you want to do a subscript, then you are going to type in, and you need to hold shift, but next to the 0, you have that underscore. So when you type that into Desmos, it's going to shift it down. So if you're doing a logarithm with a base, you're going to hit that button, it'll shift down, and then after I type in, let's say, my 2, then I just hit right, and it'll put it back up on the normal text line. So that's important to know. So a couple questions on the test will just simply ask you to be able to graph using Desmos or what have you. So you can sort of see the general shape and describe it. Now for my base logarithmic function, let's say I have a base 2 in this case. Okay, there are a couple things going on here. One, we need to be able to note that there is an asymptote. So there are no negative values for my input. I can't put in a negative value. 2 to any power is not going to generate a negative number. So if I'm talking about the domain of this function, which is one of the questions, then I would say either all positive real numbers, or if I'm doing set notation, I would do 0 to infinity. Okay. Now the range goes all the way down, it continues up. My range goes from, type it in as a note here, my range goes from negative infinity to positive infinity. Okay. And that's going to be true for most of your logarithmic functions. This is log base 2, but if I change this to log base 10, if I change it to a natural logarithm, they all model that same behavior. Okay. Now, if I have a fraction there, then it's going to invert my function. So if let's say it was log with base of 1/2, looking at log base 5 versus let's say log base 2, okay, it's going to flip the function across the x-axis, just like we see that with exponential functions, right, where I have y equals 2 to the x versus y equals 1/2 to the x. Okay, so these are both flipping the functions. In the case of exponential functions, it's reflecting across the y-axis. In the case of logarithmic functions, it's reflecting across the x-axis. So that's something to be aware of as well. So in your